This video is on quadratic applications, specifically maximizing area. So we have some word problems. It says, Jackson wants to build a rectangular fence around his pool. The store only has 128 yards of the wood he wants, so he buys it all. What is the maximum amount of area Jackson can enclose with his fence? So we know he wants to build a fence around his pool. It's rectangular, so I'm just going to draw a little basic picture over here of a rectangle. And I know that he wants to use the fence or the wood to create the entire fence all the way around that pool. So he has to use all those sides. Now, we know that he only has 128 yards, and if we have to use all of this, we want to find area, but we have 128 yards to create the perimeter. So if we say that this is his length and this is his width, we know that his perimeter is equal to 2 of his lengths plus 2 of his widths. And we only have 128 yards to do the entire perimeter. So the perimeter is actually the 128 yards. So if we set this up, we have 128 yards is equal to his 2 length plus 2 width, because that's his perimeter. But we want to find the maximum amount of area. If we know what area is of a rectangle, area is equal to length times width, which the area is what we're solving for. So we need to have length and width. Now we can take this equation and solve for one of the variables and use substitution. That's what we want to do. So on here, I'm going to take the 128. I'm going to subtract the 2L and equal it to our 2 width. Then I'm going to divide by 2 so I can get my width by itself. So our width will equal to 128 divided by 2 is going to be 64 minus 2 length divided by 2 is going to be just 1 length. The reason I want to do that is so now when I plug it in, I can actually plug in for the width and have one variable over here, have the L's, and have an A. That means that I can actually solve for something. So I'm going to rewrite my equation. My area is equal to, my length is just length, times my width is now 64 minus L. 64 minus L. Now, maximum means we want to find the vertex. And if you think about this, we have 2 different variables. This would be considered our y variable, and this would be considered our x variable. So we still want to find the vertex. The vertex in this case, for maximum, would be our x value would be our length, and then our a value would be our actual area, would be our y value. We just want to find the vertex. We need to find our axis of symmetry and then our area. So let's find our axis of symmetry. We can put this back into standard form and then find our axis of symmetry that way and then plug it in. So let's do that. I'm going to have area equals L times 64 is 64L. L times negative L is negative L squared. So I'm going to rewrite this. A equals negative L squared plus 64L. So let's find our axis of symmetry. AOS x equals negative b over 2a, which is equal to negative times our b value is 64 over 2 times negative 1. So our x is equal to, that's negative 64 over negative 2 is positive 32. So our length should be positive 32. We have positive 32, and then we want to find the maximum area. So let's go ahead and plug this in to find our vertex. So our area will equal to negative times 32 squared plus 64 times 32. So I'm going to just use my calculator to find that value. So I have negative parentheses 32 parentheses squared plus 64 parentheses times 32 close parentheses. Our maximum area is 1,024 yards squared. So our maximum area, because we're dealing with yards, is going to be 1,024 yards squared. This is the max area, because all we did was just plug that in. Maximum area is 1,024 yards squared. So if we had our length, we could actually also find our width. If we know area is length times width, just as an extra thing here, we know length times width gives us the 1,024. Well, our length is 32. So 32 times W is equal to 1,024. So 1,024 divided by our 32 is equal to 32. So really, you're making a square to have, if you want to have the maximum area, you're making a square out of that. The second question says, you have 28 feet of rabbit-proof fencing to install around your vegetable garden. What are the dimensions of the garden with the largest area? So this is where we find the maximum area, but then we find our dimensions. So we're going to follow the same process here. So we know that we want 28 feet around our entire garden. So we want all of this to be a fence. We still have our length and our width. The 28 feet, again, is the perimeter. That's how much we have for the entire thing. That's our perimeter. So perimeter is still equal to 2 lengths plus your 2 widths. So our perimeter is the 28. So we have 28 is equal to our 2 lengths plus our 2 widths. Our area is, we know, is length times width. So let's solve for one of these values. So our 28, let's just solve for our width again. We can just subtract this 2L is equal to 2W. Divide by 2, we're going to have 14 minus L is equal to W. So now we can plug this into our area. So area equals, L is still just L, times, our width is now 14 minus L. And again, we want to find the dimensions for the largest area. That's to maximize. Maximize again, largest area. So remember, our L is really our x coordinate, and our A is really our y coordinate. So we want to find our vertex, which is x comma y, so that's really L comma A. And we want the A value, so when we have the maximum area, we have our length. So if we write this out into standard form, we have area equals. Now I'm going to follow, it follows the same pattern here, so I'm just going to go ahead and rewrite it into the correct format. So now I'm going to do L times negative L, which is negative L squared. Then I'm going to have L times 14, which is a positive 14L. So again, we're going to find our vertex doing the axis of symmetry. So AOS is, I'm still going to use just x equals. It's negative times your B value, which is 14, over 2 times your A value, which was negative 1, which is negative 14 over negative 2, which is just 7. So now that we have our length is 7, we can find our vertex. So our area is going to be equal to negative times 7 squared plus 14 times 7. So we have negative parentheses 7 close parentheses squared plus 14 parentheses 7 close parentheses. So our maximum area is 49 feet squared. So our so I'm going to put this out here at the maximum area. Max area is equal to 49 feet squared. So to have the largest area, we have to have a length of 7. So max area equals 49 feet squared. And in order to have that, we have to have a length, which we already found, is equal to 7 feet. So it's area equals length times width. So I have to divide by that 7. So then that width would have to equal to 7 feet as well. Just to make sure that everything is right, we know that our perimeter is 28. So we have 2 times 7 for 2 lengths plus our 2 times our width would give us 28. And then if we had our length times width, which was 7 times 7, gives us 49, which is our maximum area. So that is correct. We have the dimensions need to be a 7 by 7. So you can write this as 7 feet by 7 feet because it's length by width. So we need a length of 7 feet, a width of 7 feet, which can be written as 7 feet by 7 feet, to get the maximum area of 49 feet squared. This one is, we have a rectangular lot is bordered on one side by a building and the other 3 sides by 800 meters of fencing. Determine the area of the largest possible lot, or the lot possible. This one, we have that rectangular lot is bordered by one side of a building and the other sides by fencing. So only 3 sides are the fence. So only these 3 sides are your fence. We don't even count that one. So this is a length, and this is width, and then this would be length. So this time, the perimeter, we don't count that. The perimeter this time is equal to, we have 2 lengths plus only 1 width. And so our perimeter this time is only 800 meters. So 800 meters is equal to your 2 lengths plus 1 W. We want to find the largest area, so we still want to maximize our area, which is equal to length times width. Same way. So let's solve for one of these so we can plug it in. So I'm going to solve for that W again because it's only 1 W, so I just have to subtract the 2L. So 800 minus 2L is equal to that width. So now I can plug it into the area part. So area is equal to our length times our width, which is 800 minus 2L. I can go ahead and rewrite this into standard form. And again, I'm going to just skip one of those steps by going ahead and putting it into the correct order. So area is equal to negative 2L squared plus 800L. So to determine the area of the largest possible lot, let's just find the maximum area. Again, we're finding the maximum, so we want to find our vertex. So our vertex, again, our x value is L, and our y value is our area, which is what we want. So let's find our AOS. X equals negative B, which is the 800, over 2A, which is that negative 2. So that's negative 800 divided by negative 4. So 800 divided by 4 is 200. So our length is equal to 200 meters. Now to find our area, we will just plug that in. So negative 2 parentheses 200 squared plus 800 times 200. So we have negative 2 times 200 squared plus 800 times 200. We get 80,000. So the maximum area, max area, equals 80,000 meters squared. And the dimensions would be, you have the length is 200, that length is 200, so that's 400. So the width would have to be 400 to make a perimeter of 800.